Alrighty, CNT140, we are looking at Chapter 13 on fiber optic connectors and splices. So our main focus here really is the different types of fiber connectors and different means of splicing fibers together. First thing we talk about is fiber optic connectors. Their purpose really is to connect two fibers together. Now, that could be a cable to a port on a device or a cable to a patch panel, which in turn connects to another cable. The sole purpose of that connector, though, is to make that connection with that port, whether it be on a device or a patch panel. So I like to think of it as almost like connecting two garden hoses together. If that connection is done right, you don't have lots of water squirting out. If the fiber connection is done well, you don't have a lot of light leaking out. Now, it's kind of a weird analogy, but you can almost kind of visualize that. They're designed to connect the fibers transmit and receive, whether it be transmit or receive, and designed to be connectable, deconnectable, if you will. On the other hand, splices are really designed to be a permanent connection, almost like gluing two garden hoses together. You know, you're not supposed to take them apart. That's what they're talking about with connectors and splices. Alrighty. So, first chunk is on connectors. Most work by simply accurately aligning the two fibers together, the two fiber ends. Well, here are the four common connectors that we run into with fiber optic. We've been mentioning these pretty much all along since CNT140, but let's take a look at them a little bit closer. One of the early connectors adopted for fiber optic connections and ports on things was our ST connector. It's a little mini twist lock, right here, a little twist lock, and it kind of does like a little quarter turn and locks in place over top of the port. So the port itself has like a little tube, a little mandrel sticking out with little ears on, that as I slide the connector on and give it a little twist lock, it locks in place. That was an early fiber connection that a lot of devices and cables and ports used. Then a lot of things migrated to the SC connector. SC is a little square plug here that just kind of friction fits in. It friction fits into the port here on the device. That's your SC connector. A lot of things migrated to that from the ST. As things went along, there were other ports out there that were being experimented with, but a lot of devices, a lot of manufacturers went with the MTRJ. The idea with the MTRJ is two fibers, there is actually two right there, bing bing, are all in one connector about the size of an RJ45, hence the RJ, register jack. All in the size of about an RJ45. And there is, it almost looks like a mini RJ45. Here is your RJ45 for the copper. And over here is the MTRJ for the fiber. So it looks very similar, just a little bit smaller. That's your MTRJ fiber port. Most connections today, right now, are using the LC connector, this guy right here. The LC are two individual connectors that this collar kind of links them together. So it's kind of like the MTRJ, but the MTRJ was all one connector with two fibers in. This is two fibers with a kind of a collar around them to hold them together. The LC connector, a lot smaller size, is what we often find being used between like switches and closets, and our small form pluggable modules or SFP modules often come with LC connector ports in them. So I've shown you here, here's your switch, here's your SFP port, small form pluggable module port, here's the SFP that will slide in, there are LC fiber ports. Okay, the thing here is be familiar with them so you know what you're looking at and or know what type of cable you need for dealing with your fiber connections. But today, a lot of things are going to be LC, just as I was going to say, just kind of an FYI. There are a couple newer connectors coming along, MPO or MTP connector. Here you have multi-fibers. There's actually 12 fibers in this connector and 24 in this one, all in one cable, designed for your ribbon cable. So a lot of trunk lines are going to this kind of fiber, 12 fibers or 24 fibers in one cable. And then here is a breakout box. The cable itself would come into the back, and as it comes into the back, this box itself splits it out to all these individual connections here. Okay, so a lot of trunk cables are going to that route. The connectors themselves The most common is having a cylindrical ferrule. The cylindrical ferrule, that is this part right here. Okay, this little ceramic part right here, cylindrical ferrule. That is the common means of kind of like aligning that fiber for connecting to another fiber. So again, think of this as like the garden hose and the water's in the middle. So I'm going to take one of these and I'm going to line it up with another one inside a port or inside a socket. So that ceramic ferrule is like the hose holding the light, and I'm going to line those two ferrules up. So what they're saying here is the most common is having this cylindrical ferrule, and most of them are ceramic. That is as I back up here, I'm going to back up here real quick. That is this part of the fiber optic connector right here, this ceramic ferrule part. Okay, very common use for a connector. Here shows you a connector kind of broken apart so you can see the pieces of it. You have the protection boot back here. In this case is a crimp style connector, so you have the crimp eyelet, and then you have the sub assembly with the ferrule in, and then this is the collar that kind of goes around the connector housing and the dust cap. Here is the SC and ST just kind of in comparison to see the pieces of a connector for terminating it. Alright, termination procedures. With our multi-mode, after we install it and pull it, it's relatively quick and easy. And single mode a lot of times is installed by splicing. This is a lot tighter and more difficult. So any types of probably fiber terminations you would deal with would be multi-mode on a premise, not too much single mode at this point. That might change as time goes down the line. Alright, so they remind us that cables can be pulled with connectors on if I think I have it right here, if we have something like this to protect all of the connections. So if I have a pull eye with a sleeve on, I can actually have a bundle of fibers with the connectors on that I carefully pull through my inner duct or my tray if I have protection for that. Cabling's got to be precise then, connectors need to be protected, but I can also terminate one end of the cable, pull the unterminated end to where it needs to be to the other closet, and then terminate it after the cable is being pulled. So I have some options there. All of these have a similar process, and they walk you through it here. Put the strain leaf boot on, strip the jacket, cut the strength member, strip the buffer, clean the fiber, adhesive, insert fiber, and then actually do the curing and polishing. Okay, well, what I'm going to do in the next section here is break down a couple different methods of termination and talk you through the process of them. Most connectors use one of these methods here, either epoxy polish, hot melt, crimp polish, or pre-polished splice option. They're actually almost kind of in historical timeline too. A lot of early connectors were epoxy polished, then they moved on to hot melt, then some moved on to crimp. A lot of things today are using pre-polished splicing connections, and that's actually the style we have in our lab. That's the style we'll end up doing in our lab too. Alright, so let's take a look. If we have an epoxy polish connector, here's an old ST connector for epoxy polish. What ends up happening is I strip off the jacket as I feed the fiber through the actual fiber itself. Okay, here's the buffer here, and then the actual fiber itself comes through the ceramic ferrule. It gets glued in place, and then you carefully score the fiber, break the stub off, and then you polish it flat with the end of the ferrule. Okay, that is typically the process. So here you go, you'll strip the buffer off, strip the jacket off, then strip the buffer off. We'll fix the fiber or the connector on the body, or put the epoxy in the connector, fit it on to the fiber, harden it, let it cure. Then you scribe the end of the fiber, out here right near the ferrule, and you carefully you actually do a couple score marks around it, then you carefully pull up on the fiber and it breaks off. Then I do an air polish, what they call it. I kind of hold a polishing membrane. You can think of it almost as super smooth sandpaper. I just kind of hold it and I gently take the fiber, the fiber connector, the ferrule, down across there to knock off the glass burr that it was created here. and then you actually put the fiber in a polishing jig. The fiber itself, the connector goes into this little, almost looks like a little hockey puck, and it goes on top of this plate that has a very, very, very fine adhesive on, or it's not adhesive, abrasive, very, very fine abrasive, almost like a very, very, very fine sandpaper, and you carefully polish the end of that fiber, and you basically a figure eight pattern. You're back and forth, figure in a figure eight pattern to polish the glass back to smooth with the end of the ferrule. That's your epoxy polish. As time went on, some of the epoxy polish terminations moved on to hot melt. Again, strip the outer jacket off, measure out distance, strip off the buffer, slide the fiber through the connector. In this case, you use a hot melt adhesive. You can almost think of it as like a hot glue, if you will, for lack of a better term. Heat it up, let it cure. Then again, I scribe cleave, air polish, polish. Okay. As time went on, I kind of zoomed by that, sorry. You're doing basically the same process. It's the adhesive that changed. The adhesive that changed here. Instead of using epoxy, it's more like a hot melt glue kind of thing. Things moved on then to a crimp style connection. Well, with a crimp style connection, what happens is the connector body itself has a pre-polished and terminated fiber stub in here. This red part on my drawing. This stub right here, this fiber stub, is already polished even with the end, and it's adhered in place. So what I end up doing is stripping the fiber and preparing it, cleaving the end of the fiber and carefully sliding it till it touches, and then I crimp it in place. So, and actually I have the connector flipped around, but it's the same idea. I'm going to slide the fiber in until it meets with that pre-polished stub. There's an index matching gel in there, and I'm going to end up crimping the fiber in place so it doesn't move. The type of connectors I often use are like Corning Unicam, for an example. Here are some examples here, and this is actually their crimping tool, their crimping vise, so it's not like a handheld crimper, if you will. I actually slide the connector in, and through a process, through some procedures, there is actually a little bar that comes over and crimps a collar here so it holds that fiber in place. So here, cut the jacket off, strip the buffer off, clean the fiber. I put it in a cleaver. The cleaver itself actually scores the fiber and pulls the stub off for you, the little broken part of the glass off for you. Then as I put it in my crimping tool here, this little bar, it's like a little bar comes over top, crimps that little silver collar to hold the fiber in place. Okay. The last style is actually a splice style. The splice style is going to work similar in nature, but instead of having the two fibers just touch each other and being crimped in place, you actually take the two fibers and you heat them until they fuse together. So I'm taking two pieces of glass and heating them enough that they get just a little bit gummy, and I kind of slide them together and then let them cool, and now it acts like one piece of glass. And you do that using a fusion splicer. So here is some fuse connectors and a fusion splicer. This is what we have in our lab. This is the style we're going to end up doing. So what happens, here is your connector, and it actually comes like so. Here is the ceramic ferrule on this end. This is the pre-terminated fiber with the little stub sticking out. What you end up doing is you load that into the fusion splicer. Here's that pre-terminated stub for you. Strip the fiber, clean it, cleave it, and then I lay the fiber into the fusion splicer here. The fusion splicer itself, okay, here's the fiber prepared laying in. Here is the connector there. The fusion splicer, these are arcs for like an arc welder. They arc, and electricity between them creates a lot of heat to cause the two fibers to basically melt, and the fusion splicer slides them together and stops, turns off the heat, lets them cool, and now they act like one piece of glass. That's a fuse connector, a fusion splice connector. Again, that's the style we'll do in our lab. I will show you how to do that and give you an opportunity to do it if you wish. I'm going to pause there. We will come back in the next podcast and continue.